Welcome to Swifter. Swifter is a browser-based automated agentic layer that uses one flow to move from user stories and specs to fully deployable effective application while connecting all your development layer in a single context. At the organization level, integrations connect Swifter to your delivery stack. Issue tracking, version control, and design systems are configured once as reusable assets. Every new project inherits those connections. A project is created with the relevant tracker, repository provider, and design system already linked. Inside each project, modules define how work is executed. A front-end module carries its own technology stack, package management, and repository strategy. Swifter supports both greenfield and brownfield delivery. Start from templates, connect an existing repository, or map to a monorepo folder. Once the project opens, requirements and backlog live together in the workspace. You can create work items natively in Swifter, picking a type, module, parent, description, and an optional Figma link, or sync from your connected tracker. The sync pulls matching items from Azure DevOps or Jira into Swifter, so your team can plan and execute without switching between systems. User stories are registered in a customer issue tracker integrated with Swifter. The story includes a business description, acceptance criteria, and an attached specification. A note on scope. Swifter picks up at a user story in your issue tracker with a business description and specification attached. It carries the work through analysis, implementation, and testing, all the way to a pull request in your Git provider. Everything before, requirements gathering, story authoring, stays in your existing tools. Everything after, CI/CD, environment promotion, deployment, stays in your existing pipelines. Swifter is the middle. Swifter studies the work item and automatically creates 3 umbrella work items, with user refinement and approval, of course. It then breaks these into executable user stories, building out a complete work item breakdown structure as suggested by Swifter and approved by the user. Swifter suggests an optimal implementation plan for large features, providing a clear summary of which user stories go into each phase. Let's switch to a sample implementation work item to show how Swifter handles the actual implementation of a user story. The description here was generated automatically by Swifter, comprehensively detailing exactly what needs to be done. The analyst studies the work item and presents a summary of changes. The backend developer then implements those changes. In the specification tab, we can see the data models and API endpoints created for this user story, including request and response models, error handling, and internal logic references for the create quote functionality. Now, all the specified data models are effectively implemented, as well as the insurance quote API with expected request/response structures and respective examples and error codes representing what could go wrong with the quoting. It is also clearly visible what internal logic is being invoked by the API. Here is backwards reference showing that there is an API endpoint using this function. We also can navigate further and see all the downstream references of the logic, as Swifter artifacts are semantically linked. Swifter includes an embedded development workspace. Developers familiar with VS Code can use the same interface to browse the source code. Here, the implemented quote controller invoking the quote service. Now let's look at the front-end work item. The front-end analyst specifies the user interface, creating component specifications, data models, and logic. The developer then implements the component according to those specifications. In the Specification tab, you can see exactly how the component was defined and built. Now let's look at testing. Here's a sample test generation work item. The description is filled in from the original business requirements document. Acceptance criteria are generated first, followed by test case scenarios, and then executable test scripts are automatically generated. In the test artifact environment, we can see the test cases generated by the agent, including the test details and steps that the test will enact while running the test case. All the steps can be directly edited and modified. In the test run section, we can see any test that the system ran and whether the test passed or failed. Users can review and edit test cases as needed, and the same applies to generated test scripts. Here you can see the test case editor, and diving into the test script, this is a playwright test that executes automatically and can also be edited as needed. Now let's see how Swifter captures test execution. You can see the video Swifter recorded while running the test script, confirming the quote was executed successfully. And whenever you implement something, you can preview it quickly in the dedicated sandbox environment for each work item. Now let's switch to the solution architect view. Typically, the solution architect starts by defining business architecture inspired by domain-driven design principles. We define business areas with their relevant information, entities, operations, and supported scenarios, each representing a domain in DDD terms. You can see the content here is drawn from your business requirements document. What's particularly interesting is the ability to see which operations depend on information from other business areas or domains, with a higher level view showing all those dependencies across the architecture. Now let's switch to the system architecture overview. The principal unit here is the deployable module. Looking at the backend API, we can see how different capabilities are implemented and how modules communicate with each other across the landscape. You can also get a higher level view of the entire system, showing how modules interact and what functional components they contain. Swifter artifacts are first-class citizens of what we call a semantic context graph. We're currently in the process of defining the architecture, so full traceability between system and business architectures is not yet established. Every artifact is versioned, and every change is part of an atomic change set that can be submitted for review. Changes are applied all at once, and when a change set is applied, it increments the version of the semantic graph. Each architecture change needs to be submitted and reviewed for full trackability and governance. The system identifies and flags logical gaps in the architecture and business logic, and flags these for user review. Once the change set is applied, coverage is reevaluated, and missing links between system and business architecture are reestablished. Every change in the edited branch needs to be submitted directly into the CI/CD pipeline and is submitted directly into your existing review infrastructure. As you can see in the report, the number of unsatisfied links decreases, and this semantic architecture becomes the new source of truth. With this linking in place, we can now see which parts of the system cover which business concepts within the business architecture. Thank you for your time, and for more information, contact us at swifter.io.